Hello students, in previous lecture we have studied about the few properties of rational numbers and the orderness, that is comparison between rational numbers. The examples which is based on that properties of rational numbers that have already solved in previous lecture. Then today we are going to study about the different forms of rational numbers. Then see here, all of you have known about that any rational number, that rational number can be written in the form of P upon Q form. The set of rational number is represented by Q and which is written in the form of P upon Q, whereas P and Q both are integers. Integers, that means these are positive or negative numbers, or it may be 0, but here one condition is there, but Q should not be 0. That means denominator should not be 0. Then the numbers which is in P upon Q form are called as rational numbers, that have already studied in previous lecture as well as in bridge course program. Then see here few examples of rational numbers, that is 5 upon 2 is a rational number. 7 upon 3 is a rational number. Minus 9 upon 5 is also a rational number. 17 upon 32 is a rational number. Then see here, these are rational numbers which can be written in different forms. See here, it is a rational number which is written in P upon Q form. 5 upon 2 is a P upon Q form of that rational number. Similarly, 4 is also rational number because we can write that in P upon Q form, that is 4 upon 1 form. As well as minus 7 is also rational number because minus 7 upon 1 means minus 7. That means minus 7 is also written in P upon Q form. Therefore, here all integers, all positive and negative integers can be written in the form of P upon Q. Therefore, all integers are rational numbers. All natural numbers are rational numbers. And all whole numbers are rational numbers. Then, see here. Here rational numbers are given in P upon Q form. But we can write those rational numbers in its decimal form also. In its decimal form. Then we can write any rational number in decimal form. Then see here, for example, 1 upon 2, that is a rational number which can be written in decimal form, that is 0.5. Similarly, 3 upon 2 which is written in the form of, see here, 1 point here 5. Then here 3 upon 2 is a rational number and it can be written in the decimal form. 1 upon 2, the decimal form of 1 upon 2 is 0.5. Decimal form of 3 upon 2 is 1.5. Then see here, we can make the practice of writing rational numbers in P upon Q form as well as in its decimal form. Then there are few examples which is given here, that is 2 upon 5 is a rational number which can be written in decimal form, that is 0.4. Then we can obtain the decimal form of that rational number by dividing 2 by 5. Then see here, 5 zeros are 0. Therefore, here 5 4s are 20, and therefore we get the value of 2 upon 5 is 0.4. Then few more examples of rational numbers are given here, that is 17 upon 36, and that is written in decimal form, that is 0.47222222. Here decimal form of this rational number is obtained by doing this calculation or by doing this division. Then similarly we can get the decimal form of few more rational numbers. See here, third one example is -7 upon 64. The decimal form of this is 0.109375. Then few more examples, that is 101 upon 8, and here we get the decimal form of that rational number 12.625. And one more example, that is 56 upon 37. 56 upon 37 is, that is 1.513 dot dot dot. That means here we get the decimal form of few rational numbers. One more example, that is 33 upon 26. Here the decimal form we get here 1.26923076923076. 692,307 dot dot. That means, see here, these are the few examples of rational numbers which is written in P upon Q form as well as in decimal form. Then that means we can classify those rational numbers into terminating or non-terminating recurring form. Recurring. That means here 2 upon 5 which is written in the decimal form, that is 0.4. Here the decimal form of that rational number is having the terminating decimal. That means here the rational number, decimal form of this rational number is terminating, because here 0.4 and there is no any numbers after 4. Then similarly, see here 17 upon 36, the decimal form is 0.47222, and here dot dots are there. That means here this decimal form of rational number is non-terminating and recurring. Recurring means here 2 is get repeated many times, therefore it is a non-terminating and recurring. Therefore this decimal form of rational number can be written like this: 0.47, the number which is repeated, that is written once, and the dot or bar is used above to that number. That means here that bar or dot indicates that decimal number 2 is get repeated many times. Then here minus 7 upon 64. The decimal form is minus 0.109375. Here the decimal is get terminating. Therefore here this decimal form of that rational number is terminating decimals. Similarly here 12.625 is also having terminating decimal form. Terminating. As well as see here 56 upon 37 is the 1.513. It get repeated many times. That means we can write it 1.513. That set of number, 3 numbers get repeated many times. Therefore bar sign is used over to that set of number which get repeated. That means this rational number, the decimal form of this rational number is having non-terminating and recurring form. Recurring. Similarly, see here 33 upon 26. The decimal form is 1.269230. 692307. See here 692307. That set is get repeated and not the 2. Only 69230 that set is get repeated. Therefore it is written like this: 1.269230. That set get repeated. Therefore only that bar sign is used on repeating numbers. Then that are the examples of decimal form of given rational numbers. Similarly, we can express the rational number in P upon Q form, and if the rational numbers are given in recurring decimal form, we can express the rational number which is in P upon Q form. Then express the rational numbers having decimal form in decimal form into P upon Q form. Into P upon Q form. Then here 0.7777 which is given here. The rational number which is given here in the decimal form, and decimal form of this rational number is non-terminating recurring form. We can convert this into P upon Q form. Let us consider the rational number. Given rational number is x. X is equals to 0.777 ... That means here x is equals to 0.7 dot, or the line is used on the repeating digit. That means x is a rational number. That rational number is written in decimal form of its recurring form. And therefore, see here, let this equation number 1. Then here only 7 get multiplied, 1 digit get multiplied. Therefore, we have to multiply that equation by 10 on both sides. Therefore, here 10x, that means x is multiplied by 10. Therefore, we have to multiply it by 10. Then here we get 7.7777 dot dot. That means here x is equals to 0.777, and when we multiplied x by 10, we have to multiply it by 10 on this side also. Then we get the value 7.777. Then here, therefore 10x is equals to 7.7. The repeating number is written once and the sign symbol is used over to it. Let this equation number 2. Then subtracting equation 1 from 2. Therefore 10x minus x is equals to 7.7 minus 0.7, and therefore we get 10x minus x, that is 9x, is equals to 7.7 bar minus 0.7 bar. Therefore we get 7. Therefore x is equals to 7 upon 9. Then see here, x is a rational number which is found in the form of p upon q. That means here 7 upon 9 is a p upon q form of that 0.777 decimal form of rational number, or it is 0.7 dot. Similarly, we can express one more rational number in p upon q form, which is given in decimal form, recurring decimal form. Then here example, that is 1.513 dot dot. Then let us consider x is equals to 1.513, that is here 513 dot dot. Then we can multiply x by here 1000. Therefore we get 1000x is equals to 1513. That means on this side we can also multiply by 1000. Therefore 0.513 dot dot. And therefore 1000x minus x is equals to, see here we have to subtract this number from this decimal form of rational number. Therefore we get 1512, that is 1512, and therefore x is here 1000x minus x, that is 999x, is equals to 1512. Therefore x is equals to 1512 upon 999. Then see here that x is rational number and here p upon q form is obtained, but we have to simplify it. That means here these two numbers are divisible by 9. Therefore 1512 upon 999, that means 9 ones are 9 ones are 9 ones are 9 ones are 9, therefore 6, 9 6 are 54, then remaining 7, 9 8s are 72. See here again, this number and this number is also divisible by 3. Therefore 3 3s are 9, 3 7s are 21, and 3 5s are 15, and 3 9s are 18. Therefore here 59 upon 37. That means here 1.513 that decimal form of rational number is written in the form of 59 upon 37. That is P upon Q form. You may solve this type of examples from practice set 2.1. Let us solve few examples from practice set 2.1. Then question number 1. See here, classify the given decimal form of rational numbers in terminating or non-terminating recurring form. Then examples. See here, classify the decimal form of given rational numbers into terminating or non-terminating recurring type. Then one of the example is given here, 13 upon 5. Then see here, we can write down the decimal form of this rational number. See here, 13 should be divided by 5. Then we get 5 2s are 10 and 5 6s are 30. Therefore, here we get 2.6. That means here the decimal form is terminating type. One more example, that is 29 upon 16. Then we have to divide it by 16 to 29 and we get 1.8125. that have also decimal form of that rational number in terminating type. Then we have to solve the few examples from question number 2. See here, the question is given here that write the following rational numbers in decimal form. Write the given rational numbers in decimal form. That means here few examples of rational numbers which is given in P upon Q form, that is 1 upon 27 upon 200. Then we have to get the decimal form of that rational number by dividing 127 by 200. Therefore, see here 127 upon 200. 2 1s are 2 0 0. 2 6s are 12. 2 3s are 6. 2 5s are 10. And here 63.5 upon 100. As here 2 zeros are there. That means in denominator 100 is there. Therefore, this number is written at 0.635. Then that means 127 upon 200. The decimal form of that rational number is 0.635. One more example that is given here. That is 23 upon 7. Then we have to find out the decimal form of it. That is 7 3s are 21. Remaining 2. 7 2s are 14. Remaining 6. 7 8s are 56. Remaining 4. 7 5s are 35. Remaining 5. 7 7s are 49. Remaining 1. 7 1s are 7. That is 3. 7 4s are 28. Remaining 2. 7 2s are 14, remaining 6. 7 8s are 56, remaining 4. 7 5s are 35, remaining 5. 7 7s are 49, remaining 1. 7 1s are 7, remaining 3. 7 4s are, see here, we get the decimal form of 23/7, and here 2857114, that number get repeated. See here, 2857114, that number get repeated in decimal form. Therefore 23/7 is the 3.2857114, that set of number get repeated here. Therefore it is written in the form of this decimal form of rational number. Then the question number 3, which is given here, in which the rational numbers which is given in decimal form, which we have to express that rational number in P/Q form. Then in question number 3, write the following decimal form of rational numbers in P/Q form. Here the example number 2 which is given, that is 0.37, and the horizontal line is above the 37 digit. That means here 0.37 get repeated many times here. That means here, therefore let us consider the rational number x is equals to 0.37 which is get repeated. See here, the 2 digits get repeated, therefore we have to multiply that x by 100. Therefore 100x is equals to 37.3737 which get repeated. Then subtract x from 100x. Then subtract this equation from this second equation. That means 100x minus x. Therefore 37.3737 minus 0.3737. Therefore we get 37. And therefore here 100 minus 1x, that is 99x, is equals to 37. And see here, therefore we get x is equals to 37/99. 37 is a prime number, therefore that means here it is the simplest form of that P/Q form of rational number. Therefore here x is equals to 37/99 is a P/Q form of 0.37 here. That is about the rational numbers and their decimal form as well as P/Q form. We can express any rational number by those 2 ways, and you may solve the examples of these type of examples from practice set 2.1 as well as from problem set 2. Thank you.